Hey, welcome to Bio-Diversity. Before we get into the episode, I just wanted to take some time to say happy holidays. Whatever you do or don't celebrate, I hope that you're having a bright and wonderful holiday season. Thank you so much for being a listener, and I hope you enjoy today's holiday special. With that, let's get into it. On with the show. Are you one of those people that just doesn't get enough Christmas? You sing the carols, bake the cookies, decorate the tree, and still, after all that, you miss Christmas when it's gone? Well, you're in good company, as coral reefs around the world may be just like you, and they get to celebrate the joy of the season with bright festive colors all year long. Because growing in festive forests of brilliant blues, reds, oranges, yellows, whites, pinks, and captivating combinations thereof is this episode's animal. And when I say forests, I mean it, because these creatures look exactly like a pair of festive fir trees, beautiful miniature Christmas cones of vibrant color swaying in the surge of the sunlit shallows. Only about an inch tall, nestled beneath them are the best possible presents of all, healthy corals and thriving biodiversity. My kind of gift. Only, as you may have surmised, these trees are not trees at all. On first glance, you might be forgiven for thinking that it's a soft coral, a fleshy snail, or even some kind of alien life form. But no, these cheery counterfeit conifers are none of these things, but rather a type of worm. So deck the halls with lots of wormies. Let's descend. Happy holidays, ocean lovers! You're listening to Season 2 of Bio-Diversity, the podcast about pelagic paradigms and coral curiosities, each episode bringing you the best in flippin' fun fish facts straight to your earholes. It's like we're the delivery drivers of peer-reviewed aquatic science, the Grubhub of fish food for your mind, the DoorDash of dope decapods. Here on the show, we examine the weird, wacky, and wonderful diversity of life that lives under the sparkling waters of our blue home. Using science as our guide, we dive deep into both the common and the rare, the exotic and the ugly. So tune in for the Tridacna and stick around for the Spirobronchus. Let's descend. Today on the show, the very appropriately named Christmas tree worm, a festive and fabulous treat. Yeah, just like the earthworm that probably popped into your head as I said the word worm. These are segmented and wiggly little critters, but before you go, ew, gross, remember that worms are such a cool branch on the tree of life, with species so diverse, unique, and important that life may not even exist without them. From the early steps that life took with deep-sea worms to the nutrient recycling wrigglers of the soil, I think worms in general deserve a lot more praise and respect than they currently get. So, let's get into it. As usual, you can find pictures of these animals gracing the cover art and in the show notes, and I highly recommend that you get a visual here, because Christmas tree worms are a visual feast. Their colors and patterns are probably the most striking thing about them, but even the shape of the fan-like spirals, the delicate, feathery appearance of the appendages that make up those spirals, even the strikingly cool eye stalks of this animal are all gorgeous. There is a reason they are a favorite animal of dive photographers, especially for those shooting macro. These details are just so visually satisfying, like an ASMR video, but for your eyeballs. And the beauty of these worms isn't just skin deep. There are more to them than just the color pop that we see at the surface. Though they might look like sugary gumdrops, they aren't just eye candy. They really are a successful group of animals that end up playing a much larger role in the overall health of the coral reefs that they inhabit. Sometimes they can be problematic to coral, but sometimes they serve as first infantry worms in a war in defending their coral homes. So, are they naughty? Are they nice? We'll ask Santa and his Christmas court at the end of the episode, but first, the basics. Welcome to Worm School. Taxonomically, today we are talking about animals in the genus Spirobronchus, of which there are many species, found in a wide range of habitats around the world where you will also find hard corals, most notably in the Caribbean and the Indo-Pacific, the Coral Triangle, Australia, these sorts of places. They are part of the polychaete flavor of worm life, also known as bristleworms, which means they are generally marine and have long, segmented bodies, kind of like earthworms, but each segment hosts a pair of fleshy, leg-like protrusions covered in bristles. Those bristles, called chaetae, are where the polychaetes get their name. Now, that description of a long, segmented, bristly worm doesn't exactly sound like what you see when you look at this colorful little feather cone. And that's because what you're looking at the surface is actually just one part of the greater whole. The trees that you see at the surface are actually an incredible set of highly adapted organs that emerge from near the mouth of the worm. You can think of these organs, commonly called crowns, as spirals made of tentacles. In biologist speak, we call those tentacles, the feathers, the branches, or whatever, we technically call them radials. So each crown is comprised of many feathery radials, each one of which is lined with smaller, hair-like cilia. It's just like tentacles all the way down. And each crown is paired such that each set of two trees that you see on the reef is actually connected to one worm. The rest of the body of that worm is contained within a secreted tube of calcium carbonate that is usually located beneath the hard surface of the coral that the worm is being hosted by. That is where you're going to find the long, segmented, bristly body that you would expect when we say bristleworm. Though, technically, those bristles are heavily reduced in these species, since they don't exactly use them much. The full bodies of these worms are usually only about 4 centimeters, or about 1.5 inches long, though the tubes that they build and live inside of can be up to 20 centimeters, or nearly 8 inches long. I guess they just like to renovate and expand from time to time. This is an incredibly unique and bizarre body plan. It's like if you decided to bury yourself in a tube in the dirt with only your face exposed, and your tongue was split into 2 spiral trees of tentacles, each with smaller, wigglier tentacles on them. You know, come to think of it, that is a really creepy idea, so all of you horror movie directors, video game creature designers, D&D dungeon masters out there, you're welcome. Head to toe, or crown to posterior tip, these worms put this body form to really good use. While all parts of the worm are interesting, if I had to pick a favorite, these crowns themselves are probably the most unique and coolest part of the animal. Unlike many other bristleworms, Christmas trees choose to stay put. They don't move from their embedded spot in the coral. But they aren't plants, and they don't photosynthesize either, so they do have to eat. So the first purpose of these crowns and their feathery radials is capturing prey. You see, seawater is absolutely chock full of tasty microorganisms smaller than our human eyes can see. From bacteria to fish larvae to tiny little copepod crustaceans, there is a microscopic buffet suspended in seawater that these worms take advantage of. As these micromorsels drift by, the system of tentacles on tentacles works in concert to trap them and move them downward, all the way through the mouth and directly into the worm's digestive tract. Do not pass go, go directly to getting digested. Commonly, this whole strategy is called filter feeding, but honestly, I just think that title does not sound nearly metal enough to convey the fact that these animals hunt prey by trapping them on a conveyor belt of death and then digest them alive. Okay, I'm not doing a very good job at conveying the Christmas spirit of these animals, but the way that they move is very pretty and very festive, because they don't have to rely on random chance for food to float by necessarily. The crowns can move in such a way that it draws a current of water toward the base of the tree and pushes it upward towards the tip, fluttering in the breeze and capturing prey along the way, which is brilliant. What's not so brilliant about this particular design is that while they can draw in water to feed, they aren't very good at pushing water away from themselves. This becomes a problem for the poor worm when your input and output tubes are right next to each other. Because the tube that the worms live in only have one opening, it does somewhat rely on external ocean currents and water movement to carry away its own excrement, else it might re-filter it. And this isn't the only instance of them eating something that they don't intend, as sand particles can also get trapped and conveyored into the mouth, which might sound kinda gross, but at least in this situation the worms can make the best of it, as they have the special ability to convert the calcium carbonate from the sand into building materials for their tubes. MacGyver would be pretty proud. And this is just one reason that the crowns are cool. I said feeding was only the first purpose of the crowns, and the second is just as essential to life. Crown power number 2 is the power of breath. Not only do these tentacled organs wiggle and move to capture food, they are also extracting oxygen from the water at the same time. As seawater is being pulled across the feathers and plankton are being caught, the radioles use diffusion to pull oxygen out, get rid of carbon dioxide, and essentially do the animal's breathing. Since this is the same way that fish breathe, it's not uncommon for folks to call the tree structures the gills of the worm instead of the crown. Now, it's not all that strange that they feed and breathe in the same place. After all, both food and oxygen go through our mouths. But this is more akin to if our tongue was our lungs, pulling oxygen out of the air while we slurped down our food. And because you know I love taxonomy, it is this fact, the fact that the crowns can breathe, is the reason that the genus of these worms is called Spirobronchus, translating from Latin to essentially mean spiro, spiral, bronchus, gills, spiral gills. So, these crowns can eat, these crowns can breathe, but what if I told you that these crowns also have a third superpower, one that solves a problem that a stationary worm must face? See, being a brightly colored and fairly tasty worm, there are those predators out on the reef that think it would be much more fun to snack on their branches rather than hang ornaments. So, in order to do anything about oncoming predators, Christmas tree worms need to know that they're coming. And unlike earthworms, who can only really sense light and dark, these marine worms actually do have eyes for this purpose. Each worm has a pair of compound complex eyes that hide near the tube opening, near the base of the trees like the last few hidden presents on Christmas morning. And these eyes are awesome in worm world, actually rivaling the complexity and function of the eyes of arthropods, like crabs, shrimp, and insects, which famously have some really cool eyes. So for a worm, that is fantastic. But there is a problem. Those eyes can really only see directly in front or behind the worm, and their vision is often blocked by the crown and the radioles themselves. Great vision isn't all that much use if your line of sight is occluded by your own tentacly branches. So to solve this problem, they pull yet another evolutionary MacGyver and improvise. Crown superpower number 3 is the gift of sight. You may not be able to tell while looking at them without a microscope, but in some Spirobronchus species, each of the radioles on the crown is speckled with multiple, small, simple eyes. Or at least something close to eyes. This is an understudied area, but those that have looked into it have found a rudimentary vision system in the form of eye spots called ocelli, lining all up and down the radioles. These simple eyes may really only be able to detect light and dark, scary shadows that pass by, but with these light-sensitive spots speckled all around the crown, it provides this light sensitivity at nearly all angles that their compound eyes might miss. And really, that's all they need to do, because they work in concert with the compound eyes to provide the worm with a 24/7 alert system to danger. If we go back to our now increasingly eldritch horror of an if it was us metaphor, now our tongues can trap prey, breathe while doing so, and wiggle a lot while being absolutely covered in eye spots. You know what? I think I'm going to drop with the creepy metaphor. It is Christmas, after all. Thankfully, the Christmas tree worm itself is anything but creepy, being their cheerful, colorful selves. And we don't actually have super solid answers as to why they are so gosh dang colorful and diverse. Does it help with their vision system somehow? Is it a warning to predators or a form of camouflage? Do they simply just feel fabulous and want the world to know? We're really not sure. But colorful and cool they are, so it is little wonder that they are one of the most widely photographed creatures in all of the Great Blue Sea. But anyone who has tried to snap a photo of them can tell you that such an endeavor can meet with frustration quickly, as these worms have a penchant for magically disappearing before a lens can get sufficiently close. This disappearing act, triggered by their vision system sensing a scary shadow, is part of their defense from those predators who would want to make a snack of them. And it is super successful, as despite their colorful look-at-me demeanor, their inability to move, and one paper calling them significantly more palatable than other polychaetes, these worms are rarely preyed upon by other animals. And they aren't toxic to predators that we know of, so their entire defense and ability to avoid being eaten is thanks to straight up running away and hiding.
When danger reared its ugly head, he bravely turned his tail and fled. Yet brave Sir Robin turned about and gallantly he chickened out.
Or, well, as much running away as a stationary worm can pull off, anyway. What it does is fully fold up its crowns into a crazy compact formation and pull them back inside the tube with the rest of the worm, usually in less than half of a second. Since the worm can't exactly go anywhere, they had to create their own hiding place, and they do that with another specialized appendage. That appendage pokes out of the tube's opening alongside the crowns and the eyes, and for lack of a better comparison, it is basically a straight-up shield. This shield, a round secretion of calcium carbonate that usually has a fair number of spikes on it, lies at the end of a highly modified radiole. They call this shield on a tentacle the operculum, and it is one feature unique to the Christmas tree worms that differentiates them from other sessile tube-building worms. When the worm gets spooked and retracts, that operculum is the last thing to clamp down, sealing the opening to the worm tube with the shield like it is the spiky doorway to a hobbit hole. At that point, the whole body of the worm and its crowns are mostly beneath the surface of the coral, so the only way to access it is through the very small hole that is sealed with a spiky plug. Not exactly worth it for whatever scrap morsel might be within. Sometimes, and it can be rather rare, a clever or fast fish or crustacean might outspeed the worm, taking a nip off the crown for a midday snack. But, clever things these worms are, even in that eventuality, they have the ability to regrow and regenerate whatever part of the body that they may have lost, so long as the whole thing doesn't get eaten. From body to crown to tube, Christmas tree worms have the ability to regenerate any part of their body, with the only exception being the defensive operculum. At this point, I was gonna make a joke about these worms being basically X-Men with mutant superpowers, like being an underwater wormy Wolverine, but hilariously, a joke like that may not be too far from the actual truth of the matter. What I mean by that is that these worms are, in fact, mutants. And what I mean by that, technically, is that one paper looked into the mitochondrial genome of these worms and found that the rate at which the DNA was changing was markedly faster than other annelid worm species. Put simply, mitochondrial DNA mutations occur, and thereby evolution happens faster, in Christmas tree worms when compared to other worm species. At least when it comes to their mitochondria. Powerhouse of the cell. So does this mean that they are evolving, on the whole, fast enough to see rapid changes in morphology and crazy new superpowered tentacled physical adaptations from generation to generation? Well, no, it doesn't. But do I still get to call them mutants and be technically correct? You bet your blastopore I do. Hey, it's me. We'll be back to the show in just a moment, but since you've listened this far, I wanted to give you a holiday gift of my own. Now, through the end of the month of January, you can get into the Bio-Diversity Patreon for absolutely free, with a 7-day free trial. Come check out the companion podcast, join our Discord community, and see what we're all about. If you like it, stick around, but if not, feel free to cancel before you get charged. Additionally, if you join the Patreon as a free or paid member, between now and January 15th, you'll be entered into a raffle to win 6 months of paid access, a $60 value, for absolutely free. Your support, even joining as a free member to join the community, helps keep this show free and releasing regularly. Links will be in the show notes. Okay, that's enough self-promotion in this little mid-roll ad. On with the show. The survival strategies of the Christmas tree worm have been extraordinarily successful, so much so that it is estimated that these worms can live to be between 10 and 40 years old in good conditions. For a worm, that is a pretty dang long lifespan, so in worm years, they're practically redwoods. The tree comparisons just keep on coming. When it's time to reproduce, they do so by using a method called broadcast spawning. Since they are, again, immobile, it's not like they can really move over to each other to engage and entangle, so to speak. So they have to release tons and tons of their gametes directly into the water all at the same time as other nearby worms. From there, they basically just hope that a sperm will meet an egg out there in the big open blue. If that does happen and fertilization occurs, a larvae will form and become part of the plankton community, floating around wherever the currents take them and rapidly growing for the next 9 to 12 days. This not quite 2-week period is the only period in their lives that they will experience freedom, because when they're done developing, they will look for an appropriate place to call home, land on some coral, and begin building. And at this point, we can't have the rest of the discussion about Christmas tree worms without sidestepping a bit to talk about the organisms that they land and grow on, the corals. So, a brief tangent to cover a few key points about corals. First, they themselves are animals, related to jellyfish actually, and have stinging venomous tentacles to prove it. They both feed through capturing prey and through a symbiotic relationship with algae that grows inside them, known as zooxanthellae. Second, overall, corals are relatively slow growing, taking years and years to grow into the full reefs that we know and see under the waves. And lastly, a lot of corals in the world are in trouble right now. Warming waters and high stress often leads to a phenomenon known as bleaching, wherein corals expel their helpful algal partners, turn bone white, and start to starve. Okay, sidestepping back to the worms, the relationship between worm and coral begins even before the larvae settle down. There has been some evidence to point to the fact that where the worm lands and settles is not all random chance. Because eyes and other chemical sensing organs develop quickly in the larvae, there is speculation that they actively look for specific corals or specific conditions when choosing a host to settle down on. And unfortunately for the worm, when they finally pick a place to stay and land, they do look really similar to the other microscopic food that the coral likes to sting and eat. But what's wild here is that there is some evidence that the settling larvae at this stage already are somehow immune to the toxic stinging of the corals, though this is an understudied area. Nonetheless, when the larvae touches down, it immediately lays down a layer of mucus all around it to attach itself to the coral and serve as a scaffold on which it will begin construction of its calcium carbonate tube that it will eventually live inside. The initial secretion happens fast, too. In the first few weeks, it will put down at least a body's length segment of tube, about 1 millimeter, every day. so that within a few short weeks, they will fully develop the compound eyes, the operculum, the crown, all of that wormy goodness, and proceed to hopefully live a long and fulfilling life. I mentioned a few times already that oftentimes the tube of the worm is buried beneath the surface of the coral. Because of this fact, many assumed that the worm accomplishes this by burrowing or boring into the coral, harming it. But really, this isn't the case at all. Studies have shown that the worms have a disposition for growing towards and across the living coral surface, not into it. And the slow-growing corals end up, over years and years, growing around the tube and fully encasing it in the coral skeleton. So after this years-long process, you have what you most often see when diving: colorful crowns dancing on the surface of corals, with the rest of the worm tucked safely away beneath both its protective tube and the coral skeleton to boot. But is this good or bad for the coral? This brings us to the controversial portion of this episode. In an ecological context, the question is, are these worms naughty, or are they nice? See, whether or not the presence of Christmas tree worms hurts or helps the coral reef is a subject of pretty hot scientific debate, and there are two convincing arguments on both sides. But at the end of the day, Santa must put them on one list or another. So let's hear out both sides of the argument here in Santa's court. As an opening statement, the prosecution calls for a naughty verdict and has offered the following evidence. One particular study found that the movement of the worm's retreat can, on occasion, scrape that spiky operculum along the living coral tissue and cause abrasions and damage to their coral hosts. When this happens, the problem can be far more severe than a simple scratch. Corals don't have antibiotic ointment and band-aids after all, so these wounds have the very real possibility of increasing coral susceptibility to disease. It can also lead to tissue death in those particular areas, which is a problem in and of itself, but can also lead to something much worse: an open invitation for turf algae to anchor onto the dead tissue and move in. Turf algae, green, short mats of the stuff, can be one of coral's worst enemies. And though the relationship between them is far more complex than what's presented here, in a nutshell, algae like this can smother the corals, blocking light and really inhibiting the growth and recovery of damaged reefs. If you have bleached coral and algae moves in, well, you can kind of forget about the recovery of that coral. Plus, many studies have found that this antagonistic algae likes to make its home on the opercula of the Christmas tree worms themselves, and that severe damage to the coral is far more likely when they are scratched by an algae-infested operculum, as opposed to a clean one. Could be that a colonized operculum is what introduces the algae in the first place, creating a spot for settlement with the damage. So, that's not great. And furthermore, some evidence suggests that the crown of an alive worm can stress out and irritate the polyps on the coral that they're next to. In large groups, the thinking is that they both block the sunlight needed by the coral's symbiotic zooxanthellae, smothering the coral to death, or failing that, they could provide enough minor irritation to stress the corals out, meaning increased susceptibility to things like warm water events and climate change, potentially worsening the effects of bleaching. Unwelcome house guests, if you will. But the defense has an argument too. The evidence for a nice verdict posits that the action of these worms may actually do the opposite and prevent bleaching and help bleached corals recover. The mechanism for this, as the argument goes, is fairly straightforward. The pulsing movements of the worms that draws water under and up through their crowns just so happens to also be a great pathway for keeping cool, clean water flowing across the surface of the coral. This not only helps clean out the muck and toxins off of the coral's surface, it also helps draw food to the coral's own feeding tentacles and acts as a way to cool the polyps down, potentially increasing their resilience to warming waters and ultimately bleaching. Remember that bleaching is caused when corals expel their symbiotic algal tenants, the zooxanthellae, usually due to warm water and stress. Unlike the antagonistic rival turf algae, zooxanthellae algae are helpful little friends that photosynthesize and provide some of their nutrients to the coral in exchange for protection. Corals that bleach can actually recover if the water cools and they can re-recruit more zooxanthellae to move back in. One paper presented by the defense argues that certain zooxanthellae are highly attracted to places with higher nitrogen content, and that the biological processes of Christmas tree worms elevate the nitrogen content of coral ecosystems. Thus, it is not out of the realm of reasonability to conclude that the presence of these worms on bleached coral may help in re-attracting zooxanthellae, ultimately reviving the dying coral. And the final argument, laid out for a nice verdict, hinges on one more super unique behavior of these worms. See, when their host corals are attacked by one particularly vicious predator, the crown of thorns starfish, these worms shed their shy behavior and go to war in defense of their calcified home. Striking video evidence shows that when this voracious predator, one of the major threats to stressed corals in places like the Great Barrier Reef, tries to walk across and chow down on coral polyps when Christmas tree worms are present, the worms will actually come back out of their holes and push their spiky operculum into the star's tube feet. In high enough numbers, the worms can literally annoy the starfish enough to cause it to back off, thus saving the coral from ultimately being digested alive. So ultimately, which is it? Are these worms naughty, or are they nice? Could it be that, much like reality, and much unlike the colorful worms themselves, the truth exists as some shade of gray? Sometimes they could be helpful, sometimes they could cause damage, and sometimes outside factors like the presence of algae and temperature of the water might confound the whole thing further and make things even less black and white. As the science currently stands, Santa sees this as an issue of balance. It is super cool to hear of the benefits that these worms bring to the reefs, but there can also be too much of a good thing, which does lead to detriment and deterioration. So until more research is done on these criminally understudied creatures, Santa's court ultimately relies on the North Pole's greatest legal principle: nice until proven naughty. Court is adjourned. That's gonna do it for today's episode of Bio-Diversity. Santa, if you're listening, I would really love for my present this year to be a reversal in the downward trend of coral bleaching and death. Or, I guess if that's not something that the elves can build, maybe help fund more exciting marine science, like studies on Christmas tree worms? I know that the scientists could really use it right about now, and what better way to spread the holiday spirit above and below the waves? And hey, do you have an ocean lover in your life? Why not give them, or yourself, the gift of more biodiversity? The gift of a Patreon subscription comes with all sorts of fun stuff, from bonus episodes of the companion podcast, Deeper Descent, to full interviews, seafood recipes, retrospective re-listens, and more. You'll also get to be a part of our patron-only community Discord, where you can chat ocean adventuring, conservation, science, cooking, fishing, or any kind of topic that your ocean-loving heart desires. Big shout out to my current patrons at the Adventure to the Abyss tier, Laughsalotl and Vorpal Gnome. Your support means the actual world to me. And to all of you listeners out there, thank you so much for tuning in. I hope that no matter who you are and what you do or don't celebrate, that your holiday season is as bright and cheery as the radioles of the Christmas tree worm. I'll see you all on the next dive.